Okay, so we're going to do question 4.1. Now, when who has a current wealth of $10,000 decide to take advantage of a free trip to Las Vegas to play roulette. Okay, so his utility function is given by utility of y equal to square root of y, where y over here is the amount of money he will be ending up with after the trip. Okay, so that's going to be just his current money, current wealth, minus whatever adjusted by whatever amount he ending up in winning or losing from playing from gambling. Okay, so basically he can take one of the two gambles as follow. Okay, so gamble one is going to it's going to bet 1,000 on red. If red is coming up, then with the probability of 18 over 38, then he's going to win 1,000. Otherwise, he's going to lose $1,000. Now the gamble two is he's going to bet 500 on a single number 00. Now if 00 comes off, then with a probability of 1 on 38, then he will win 35 times of the 500, which is 17,500. However, otherwise he's going to lose 500, which is the amount of money that he bet. So question asking you, are these gambles are fair gambles? Okay, so what determines whether a gamble is fair? Now, so we say gambles, okay, are fair when the expected income or the expected payoff is going to be equal to 0. Okay, which is basically means that in the chance of given the probability of losing and the amount of losing and the probability of winning with the amount of winning, the expected value or the expected payoff you get at the end will have to be equal to 0 for the gamble to be a fair gamble. Okay, so the gambles are fair if and only if the expected payoff, okay, equal to 0. Alright, so we're going to see whether that is going to be the case over here. So we do with gamble 1 first. Now for gamble 1, the expected payoff is going to be with a probability of 18 on 38. The player is going to win, and he's going to get $1,000. Okay, so this probability, the player is going to get $1,000. Now, however, with a probability of which is basically the remaining probability, so that is just 38 minus 18, so it's basically 20 on 38 chance that the consumer or the player is going to be losing, and he will lose $1,000. Okay, so therefore the loss is going to be $1,000. So the payoff is negative 1,000. Okay, so therefore, so if you okay, so if you use a calculator, you are going to get it's going to be negative 52.6. Okay, and as you can see, it's smaller than 0. So therefore, we can see that the gamble is not fair. Okay, which is basically the expected payoff is being negative. So we say that gamble 1 is not fair. Okay, how about gamble 2? Now, gamble 2 is telling you that with the probability of, so the expected payoff is with the probability of 1 on 38, the player is going to win, and he is going to win 17,500. Okay, however, with the remaining probability, which is 37 on 38 chance that he's going to lose, and he's going to lose $500. Sorry, I should have a negative there. Okay, so if you calculate this, it's going to give you negative 26.3, and therefore again it is smaller than 0. So again we say that this gamble is not a fair gamble either. Alright, which is basically what we would expect to get in the casino. Okay, so in the casino we will never get any fair gambles, or the gambles as basically not fair. Okay, and the people who are taking gamble are basically the one who's having very high risk. Okay, so they're basically the risk lover, where even though the gambles are not fair, they will still be willing to take it. Okay, so Pat be asking you, if Wen is forced to take one of these two gambles, which one would he prefer? Okay, so right, so the player is going to prefer, okay, the gamble that results in a higher expected utility for the player. Okay, so what we have to do is to find the expected utility for each of the gamble and see which one is bigger. The player is going to prefer that one. Okay, so again we are going to do for gamble 1 first. Now the expected utility is going to be okay, so I'll say expected utility 1 is going to be the probability of winning, which is 18 on 38. Okay, times the utility that the consumer will get from winning. Okay, so outside is the utility of winning. Alright, for gamble 1, plus the probability of losing, which is 20 on 38, and multiply by the utility that the consumer is going to get from losing. Okay, so that's UL. Alright, so now if the consumer is winning, he is going to get $1,000. Okay, so therefore his utility is going to be the square root of the total wealth that he's going to get, which is a 10,000 from the beginning, plus another 1,000 that he's winning from the gamble. Now, with the probability of 20 on 38, the consumer or the player is going to be losing, and he's going to lose $1,000. Okay, so therefore the utility is going to be the square root of the total wealth that he's going to have, which is going to be a 10,000 initially minus 1,000 that he's going to lose. Okay, so that is going to give you so square root of 11,000 times 18 divided by 38. Okay, and plus square root of 9,000. Okay, so that's going to give you 99.61, and that is the expected utility from gamble 1. Okay, so we're going to do very similar thing for gamble 2 and see what is going to be the expected utility for gamble 2. Okay, so over here, gamble 2. Now expected utility for gamble 2, again, it's just the probability of winning, which is 1 on 38, times the utility of winning gamble 2, plus the probability of losing, which is 37 on 38, times the utility of losing gamble 2. Okay, so therefore it's going to be 1 on 38. Now if the consumer is winning, he's going to get 17,500, and together with the 10,000 he's having initially, he's going to have 10,000 plus 17,500. However, if he is losing with a probability of 37 on 38, he's going to get 10,000, which is the original wealth, minus the 500 that he's going to lose. Okay, so if you use a calculator, that is going to give you 99.27. Okay, so as we can see, the expected utility from gamble 1 is higher than the expected utility that the consumer is going to get from gamble 2. So, so therefore, expected utility from gamble 1 is bigger than expected utility in gamble 2. So therefore, the player is going to prefer gamble 1. Alright, so question part C, if the consumer or if the player isn't forced to play any gamble, would he take a gamble? Okay, so if he can choose not to play anything, will he take a gamble or not? So basically now what we have to compare is to compare his utility from not taking the gamble and the utility from taking the gamble and see which one is bigger. Okay, so we know that if he is taking the gamble, he is going to take gamble 1 because that is going to give him a higher expected utility. Alright, so okay, so if when does take a gamble, okay, he is going to take gamble 1, okay, and therefore his expected utility is going to be 99.61. Now we try to find what is going to be his utility if he doesn't take any gamble. So if when does not take any gamble, what would be his utility? Okay. Now, if he doesn't take any gamble, he's not going to lose anything. However, he's not going to win anything either. Okay, so therefore, his utility from not taking the gamble is going to be just the original wealth that he's having at the moment. So therefore, the utility would just be the square root of a 10,000. Okay, which is the total amount of wealth that he is currently having, and that is going to just be 100. Okay, so as you can see, the utility from not taking any gamble is higher than the utility of taking a gamble. So therefore, if when has a choice of not doing any gamble, he will not do it. Okay, so therefore, when will not take any gamble.